Today, our topic is implementing of stacks using arrays. So, let me explain to you today about stacks using arrays. So, let me open Pinebrush and let me explain the concept of stacks to you. So, basically, what is a stack? A stack is a last in, first out data structure. So, let us type it. Stack is, let me increase the font. 1 minute. Stack is last in, first out data structure means into the stack we can insert elements, and the element which we inserted last will be deleted first. So that's why it is called as last in, first out data structure. So basically stack is last in, first first out, last in, first out data structure, right? So let me draw the figure of a stack and explain to you how I will be inserting elements into the stack and how I will be removing elements from the stack, and what is inserting element into the stack called as, and what is deleting element from the stack called as. So first of all, let us fix the size of the stack. Let the size of the stack be, let the size of the stack be 5. It means in my stack, I can store, insert, and delete 5 values. So let me make 5 partitions in the stack like this. This is first S of 0 in my stack 0th place. In my stack S of 1, this is S of 2, and this is S of 3, and topmost one is S of 4. So let us write the names of those. This is nothing but, this is nothing but, if your stack name is S, this is nothing but S of 0. And this is nothing but S of 1. And this is nothing but S of 2. S of 2. And this is nothing but S of 3. And this is nothing but S of 4. Right. So the 5 cells in my stack are named as S of 0, S of 1, S of 2, S of 3, and S of 4. Now, let us store values into the stack. To store values into the stack, we use a variable with the name top. This top value is initially assigned to -1. Top is equal to minus means our stack is empty. It means there is no single value stored in the stack. So, first of all, our top will be -1. So, when we insert a value into the stack, our top value will be incremented, and into that position, we will be inserting a value. So, let me do it out here. So, let my top value be first 0. Top is -1 initially. To insert the first value, my top will be 0. Then S of top means S of 0. There, I will be inserting some value. Let it be 10. Again, you will increment top value one more time. Then your top will be 1. And then you will be inserting next value into the stack. Let it be 20. Then again, you will be incrementing top value. Let it be 2. And in the stack, we will be inserting the value 30. Later, top value will become 3, and in the stack in S of 3 position, we will be inserting 40. Finally, top value is 4, and in that position, we will be inserting 40. 50, sorry. Let me do it. I'm inserting 50, and let me show you how to do this. So here, I am inserting 50. Done. Now, can I insert one more value into the stack? No, I cannot insert one more value into the stack because already the stack is full. So how do you write isFull function for the stack, which describes whether the stack is full or not? Let us do it now. So we can do it in this way. Integer is full. Function name is isFull. And if it is stack is full, if the stack is full, it returns 1, else it returns 0. So isFull, this is the flower bracket. And then if my top value is equal to, what is the size of your array? 5. So size minus 1. When the top value becomes 4, then our stack is full, for which we will return 1. So if we return 1 in isFull function, it means our stack is full. Else return 0. If we are returning 0 means our stack is not full, and in our stack still there are some places where we can insert new elements into the stack. So this is called as isFull function. And using this function, we can know whether the stack is full or not. So returning 1 means it indicates that our stack is full. So here we can write comment, what we can write, our stack is full. If we return 0, what does it mean? Stack is not full. Right. Now, how do we insert number into the stack? For that, let us try to write a function. So let me write the function for inserting a new value into the stack. Inserting new value into the stack is called as push operation, and removing value from the stack is called as pop operation. So let us first of all learn how to do push operation. So what is push? Pushing means inserting. Let me increase the size of the text box. Push means one little more. Let us do it. Push means inserting value into stack. Pop means removing value from stack. There is one more operation called as display means showing values in the stack. So let us start with push operation. How do we insert new values into the stack? So let us write push function, and I will explain to you how to insert new values into the stack. So let me write the push function. So the function name is push. And before we try to put new element into the stack, we should first check whether there is place in the stack to insert new value or not. So that we can know by using isFull function. If isFull, it means if the stack is already if the stack is already full, if is full, what do we print? We print that stack is full. There is no place to insert new value. Else means the stack is not full and we are having a place in the stack to insert new value. So let us insert new value. To insert new value, we will increase the top value from -1 to 0. It means we will do top plus plus. It can be -1 to 0, 0 to 1. Whenever we insert a new value, the top value should be incremented. Yes, I have incremented the top, and you take the value to be inserted into stack. Printf, enter, enter, enter value into stack. Then you take the value by using scanf. Scanf %G ampersand. Let the value to be inserted into stack be x. And then in S of top, in the stack, wherever there is in that position, we will be inserting the new value x. So this is the code for pushing a new value into the stack. So this is how we will insert a new element into the stack. Hope all of you followed uh, is full function, which is used to find whether the stack is full or not, and then push function, which is used to insert a new value into the stack. Next, let us see is empty function, which can be used to see whether the stack is empty or not, and pop function, which is used to remove the elements in the stack. So let us start. Let us start. So let me show you what I want to do. So let us draw the stack first. So I am drawing the stack over here. Let me do it. So my stack is having how many values? 5 values, because the size of my stack is 5. 3 cells, 4 cells, 5 cells. So if the top is empty, we cannot delete values. How do we know whether the stack is empty or not? So for that, if our stack is empty, our top will be -1. It means there is no value in the stack. So if the top value is -1, it indicates that our stack is empty. So let me do it. And let me write is empty function first. So int, the function name is empty, is empty. And if our top value is -1, it indicates that our stack is empty. So stack is empty means to indicate that stack is empty, I will return 1. And if top is not -1, definitely there is some value in the stack. Then it indicates that stack is not empty. So let me return 0. So if the stack is empty, this function returns 1. So if you return 1 means our stack is empty. So if you return 1, our stack is empty. So if you return 1, let me write down stack is empty. Empty. And if we return 0, we return 0. Stack is not empty. Okay. Now let us see how to remove elements from the stack. So first of all, let me insert values into the stack. So the first value is 10. Top is 0. I will put 10. Then I will insert 20. Then top will be 1. Then I will insert 30. Top will be 2. I will insert 40. Top will be 3. And I insert 50. Top will be 4. So what is the present value of the top? So top value is nothing but 4. So let us see how to remove an element from the stack. To remove element from the stack, we use pop function. So let us describe pop function. So void pop. Before removing the element, we should check whether there is element to remove in the stack or not. So we can check whether there is element to remove in the stack or not by using isEmpty function. So isEmpty. So if the stack is empty, we cannot remove values. So we will say that stack is empty. Stack is empty. If there are, the stack is not empty, it means there are some values in the stack. We can remove them. So how do you remove? X is equal to S of top. So from the stack, topmost element will be retrieved into X. In our stack, topmost element is 50. So it will be retrieved into X. After retrieving 50, so as 50 is deleted, top will be moved to 40. So automatically we will do top minus in order to move the top from 50 towards 40. That's it. Our work is done. This is how we delete an element from the stack. If empty, we will say that stack is empty. Or else we will remove an element from the stack by using S of top and fetching it into X. And then we will decrement the top value by doing top minus. So let us see diagrammatically how we will do this. So first of all, I am removing 50. So how do I remove? So I am removing 50. I have removed 50. Then automatically top minus will be done. Top minus will be done. And the top will become 3. Then you remove 40. I am removing 40. Then again top minus will be done. And my top value will become 2. So top will become 2. Again, if you remove 30, if you remove 30, again it will become top minus and my top value will become 1. Now, if you remove 20, then again top minus will be done and my top value will become 0. Finally, if you remove 10, top will become minus and my top value will again become -1, which indicates that my stack is empty and I can no more delete any elements from the stack as it is empty. Hope all of you have followed full, is empty, push and pop operations in the stack. Now, let me explain to you about the display function, which is used to show the elements in the stack. So how do we write display function? Void display void display. So if stack is empty, we cannot display anything. If is empty, you will say that printf stack is empty. If stack is not empty, starting from top value, where is top value? Suppose there are 10, 20, 30, 40. Top is at 4. Starting from top 4, that is from 50, then 40, then 30, then 20, then 10. All the values should be displayed. So I will start a for loop starting from I is equal to top. I is equal to top. And I greater than or equal to 0. I minus minus. I will print the elements in the stack. So printf percentile D S of I. In this way, I can print the elements in the stack. So first I will be displaying, since top is 4, first I will be displaying 50. 50. And then I will be displaying 40 when top is 3. Then when top is 2, I will display 30. And then when top is 1, I will display 20. And then when top is 0, I will be displaying 10. In this way, we will display the elements starting from 50. We will be moving towards 10. So you will get the values in the display function. How you will get? You will get 50, 40. You will get 50, then 40, 50, 40, 30, then 20, and then 10. I hope all of you understand what is a stack. That's the last in first out data structure. And all the operations that can be performed on stack, that is useful, is empty, push function, pop function, and display function. So that's all for today. So let me stop sharing the screen and let me stop the recording.